What is the main problem addressed by the language model evaluation harness described in the paper?
The main problem addressed by the language model evaluation harness described in the paper is the challenge of reproducibility and transparency in evaluating large language models. The paper highlights the difficulties researchers face in reproducing results reported in various papers and carrying out new evaluations themselves due to inconsistencies, biases, and lack of access to original evaluation code. The language model evaluation harness aims to provide a flexible evaluation library that serves as research infrastructure for evaluation, enabling researchers to run any benchmark on any model easily. It encourages sharing exact prompts and code, avoiding copying results from other implementations, providing model outputs, performing qualitative analyses, and measuring and reporting uncertainty to improve evaluation rigor and transparency. Additionally, the harness addresses challenges in benchmark design, implementation difficulties, lack of agreement about fair comparisons across models and methods, difficulties in comparing scores across different evaluation setups, and the fast-changing progress and conventions in NLP research.
Can you explain step by step how the lm-eval library enables researchers to run any benchmark on any model easily?
The lm-eval library enables researchers to run any benchmark on any model easily through several key steps outlined in the paper. Firstly, lm-eval is designed to be a flexible evaluation library that serves as research infrastructure for evaluation, addressing the challenges of transparent and reproducible evaluation of large language models. The library allows for the contribution of two types of implementations: evaluation tasks and integrations with novel LM implementations. Tasks are modular implementations of evaluation tasks, implemented as a task class using a common API, which allows for tasks to be collected in a common library, extended easily, and shared reproducibly among practitioners. Users can implement tasks either via YAML-based configuration files or by subclassing the provided task class and providing custom code for specific methods. Secondly, lm-eval provides an LM API that allows arbitrary software libraries or language model architectures to extend a provided interface for LM objects. This abstraction allows for easy integration of different models into the evaluation process. The LM API operates upon dispatched requests, which consist of mapping string inputs to some string or probability as output. This design simplifies the process of evaluating different models by treating a neural language model combined with its tokenizer as a single system being evaluated. Additionally, lm-eval supports three core types of requests that can be sent to a language model: conditional log likelihoods, perplexities, and generation. These requests allow for different types of measurements to be performed to observe a model's response or latent capabilities in a prompted format. By providing standardized implementations of common tasks, lm-eval ensures that practitioners can report on tasks consistently and evaluate models on the same prompts and implementations as other users of the library. This standardization, along with versioning of tasks and support for qualitative analysis and statistical testing, encourages reproducible evaluation and improves the robustness and confidence in novel evaluation results.
What are the theoretical or practical benefits of using automated metrics like Blue and Rouge in language model evaluation, as mentioned in the paper?
The theoretical and practical benefits of using automated metrics like Blue and Rouge in language model evaluation, as mentioned in the paper, lie in their reproducibility, cost-effectiveness, and ability to address the key problem in evaluating language models. These automated metrics offer advantages such as being fully reproducible, easier and cheaper to compute, and can avoid some of the issues faced by human studies. Blue and Rouge directly tackle the key problem by measuring the distance between a generated response and a gold standard one, typically through n-gram overlap. Despite their flaws and reproducibility challenges, these metrics provide a standardized way to quantitatively assess the performance of language models. Additionally, model-based metrics leveraging large language models as graders have gained momentum, serving as proxies for human preference evaluation. While these metrics also have flaws and reproducibility issues, they offer a different approach to evaluating language models. Overall, automated metrics like Blue and Rouge provide a consistent and cost-effective way to evaluate language models, helping researchers track progress and compare different methods in a standardized manner.
How does lm-eval ensure reproducibility in evaluation runs according to the paper?
lm-eval ensures reproducibility in evaluation runs by providing a standardized implementation of common tasks, allowing practitioners to report on these tasks and ensure they are evaluating on the same prompt and implementation as other users of the library. Additionally, lm-eval reports a version field alongside task results, which is incremented each time a task must be modified in a way that affects its scoring. This versioning system enables researchers to reference the specific version of the task used, ensuring future research can reproduce reported results even if task implementations have bugs or need to be updated. By using lm-eval, researchers can have confidence that the results from prior work match what they would have obtained had they rerun it themselves using that version of the library.
What challenges are highlighted in comparing scores across different evaluation setups in the context of language model evaluation?
The challenges highlighted in comparing scores across different evaluation setups in the context of language model evaluation include the sensitivity to divergences in evaluation methodology and setup. For example, different prompting and scoring styles can significantly impact model performance and the validity of comparisons. If models use different approaches or do not disclose their exact settings, it becomes impossible to reliably compare their stated performance. This issue is exacerbated when model creators use different prompting and scoring styles and compare their models to baselines using numbers from technical reports, leading to nonsensical comparisons. Even with better statistical reporting, such as the use of confidence intervals, the variations in model performance across different measurement settings cannot be captured. Therefore, it is crucial to avoid copying numbers from other papers' reported evaluation scores, and to share full details of one's own evaluation setup to ensure rigorous and meaningful comparisons across different evaluation setups.
Based on the paper, could you elaborate on the major components and design philosophy of lm-eval, focusing on the evaluation tasks and lm-API mentioned?
The major components of lm-eval include evaluation tasks and the lm-API. The evaluation tasks are modular implementations designed as task classes using a common API, allowing for easy extension, implementation, and sharing among practitioners. Tasks can be implemented through YAML-based configuration files or by subclassing the task class and providing custom code. lm-eval provides various implementations for common tasks and accepts new tasks from the community. The lm-API allows for arbitrary software libraries or language model architectures to extend a provided interface for LM objects. It abstracts tokenizers within the LM class and treats the neural language model combined with its tokenizer as a single system being evaluated. The LM API supports three core types of requests: conditional log likelihoods, perplexities, and generation, enabling the evaluation of language models in various ways. The design philosophy of lm-eval focuses on providing a standardized and flexible framework for evaluating language models, allowing for reproducibility, modularity, and ease of use in conducting evaluations across different tasks and models.